Dear friends, welcome to a personalized episode of Enlighten Me. Today, we discuss the challenges AI companies face in turning models into products, how SaaS companies adjust free offerings, and techniques for achieving the fastest code in networking. Stay tuned for insights on these topics and more. How did AI companies find themselves grappling with the challenges of turning models into products? Let's explore the journey and the obstacles they face. When ChatGPT was launched, it quickly caught the public's imagination, leading to a surge of enthusiasm among AI developers. However, this excitement often clouded their understanding of the market. They underestimated the significant gap between creating a proof of concept and developing a reliable product. This misjudgment led to two flawed commercial approaches. OpenAI and Anthropic focused solely on building models, neglecting product development. For instance, OpenAI took 6 months to release a ChatGPT iOS app and 8 months for an Android app. Meanwhile, Google and Microsoft integrated AI into everything in a rushed manner, without considering which products would genuinely benefit from AI. Both groups overlooked the fundamental principle of creating something that people actually want. They assumed that the versatility of language models would naturally align with market needs, bypassing the necessity of finding a product-market fit. This oversight meant that early adopters of these models were often bad actors who were more motivated to misuse the technology, resulting in a poor public perception. Companies are now shifting strategies. OpenAI is transitioning from a research lab to a more conventional product company. Anthropic, while still focused on research, has also recognized the need for product development. Google and Microsoft are gradually learning, influenced by Apple's more measured approach to AI integration. Let's delve into the 5 major challenges that AI companies need to overcome to make generative AI commercially viable. First, cost is a significant barrier. Even simple chat applications can become prohibitively expensive as conversations grow longer. While there have been substantial cost reductions, making AI truly affordable remains a challenge. The cheaper the model, the more retries can be made within a budget, improving accuracy. Second, reliability is crucial. AI systems need to function consistently. Consumers expect AI to work like traditional software, but achieving perfect accuracy with machine learning systems is inherently difficult. Developers have to adapt AI to meet user expectations and ensure it works deterministically. Third, privacy concerns are paramount. While language models are trained primarily on public data, AI assistants often require access to personal information to be effective. Companies need to navigate these privacy issues carefully, balancing innovation with user trust. Fourth, safety and security are critical. Unintended biases, misuse, and hacking pose significant risks. Companies need robust defenses against potential security threats, such as AI worms that could spread and cause harm. Finally, user interface design is essential. Users need ways to intervene when AI goes off track, especially in high-stakes applications like flight booking. The interaction needs to be seamless and intuitive, particularly for natural language interfaces. In summary, while AI capabilities are improving rapidly, developers must tackle these socio-technical challenges to integrate AI into existing products and workflows effectively. This process will likely unfold over a decade or more, rather than in the immediate future. Now, let's talk about how SaaS companies manage their free offerings in response to rising capital costs. Have you ever wondered why some software companies change what they offer for free? The world of SaaS, or software as a service, is always adapting. When interest rates go up, the cost of capital increases. This means SaaS companies need to be smarter about what they give away for free. When money is cheap, companies like Slack, Asana, Airtable and MailChimp could afford to be generous with their free tiers. But as capital becomes more expensive, these companies have started tightening their free offerings. They need to focus on maintaining their margins because serving each customer costs more. For growth stage companies, changing the free tier can be tricky. These companies already have paying customers and a reputation to uphold. They want to keep growing without slowing down, even while trying to make more money from their existing users. So, how do they decide what to change in their free tier? They might limit features, restrict usage rates, set maximum numbers of users, or put time limits on certain features. The first step is to identify if their free plan is not working. A good indicator is if less than 5% of free users convert to paying customers within a year. However, low conversion rates are just one sign of a problem. There are three main pitfalls SaaS companies face with their free tiers: being too generous, too restrictive, or having a paid tier that's too expensive. If a free tier is too generous, a large number of active users in the free plan might never upgrade. This was common when interest rates were low, making it easier for companies to offer more for free. The key is to create the right level of friction to encourage upgrades. For example, Slack changed from allowing 10,000 messages in a free account to a 90-day message history. This way, users still see the value but are nudged towards paying for more extensive use. On the flip side, if a free tier is too restrictive, users might not stick around long enough to see the value of the product. For instance, imagine if Slack didn't save any messages beyond 1 day. Users wouldn't get the full experience of the product. To fix this, companies need to ensure their free tier helps users reach an aha moment where they see the product's true value. This might involve adding more features to the free tier. Lastly, if the paid tier is too expensive, even willing users might stick with the free version. This often happens with prosumer products where users know the paid version is better but can't justify the cost. Companies might need to lower the entry price for the paid tier or add a cheaper, intermediate tier. For example, a company with a very high starting price for its paid tier found that many users were sticking with the free plan. After lowering the cost of entry, they saw a significant increase in conversions. In summary, optimizing free and paid tiers is crucial for SaaS companies, especially when the economic landscape changes. Listening to customer feedback and observing user behavior can guide these adjustments, ensuring that the offerings are both appealing and profitable. Now, let's look at how networking code can achieve ultra-high-speed packet processing through various optimization techniques. What does it mean to claim you have the fastest code in the world? How fast is fast? Let's start with some context from the world of networking. These days, 100 gig NICs, or network interface cards, are quite common. But what does that actually mean? If you make some assumptions about packet sizes, a 100 gig NIC translates to about 10 million packets per second. In terms of time, that means you have about 100 nanoseconds to process each packet. To put it into perspective, imagine a beam of light traveling across a room in that time frame. That's incredibly fast. So how do you achieve such speed? We'll discuss 7 different techniques used to optimize code for high performance. These techniques are practical and have been tested with real code examples. For instance, consider how you use your phone with 5G connectivity. The data from your phone goes to a nearby mobile tower, and from there, it gets aggregated in what's called the 5G packet core. This core is essential, the brains of the operation, if you will. It processes packets by matching headers, applying policies like quality of service or network address translation, and then sending the packet out to the internet. To simplify our example, let's consider a basic packet processing device. This device matches packet headers and rewrites parts of them based on policies. We'll start with a simple code written in C. Initially, this code might take about 1,000 clock cycles to process each packet, which is slow compared to our target of 300 clock cycles. Let's start optimizing. One basic technique is using inline functions. When a function is called frequently, like our process.packet function, the overhead of function calls adds up. By inlining the function, you eliminate this overhead and speed up execution slightly. Next, we should let the compiler do some of the work. Compilers are good at optimization, especially when you use flags like -03 for general optimization and specify your target architecture. This allows the compiler to use advanced instruction sets like AVX, which are designed for high performance. Another technique involves using vector instructions, such as those provided by Intel's AVX2 or even AVX 512. These instructions allow you to perform operations on multiple pieces of data simultaneously. For example, using a vector instruction to perform a logical AND operation on 8 integers at the same time can significantly speed up processing. We can also improve our data structures. Instead of a standard hash map, consider using a Swiss table, a more cache-efficient hash table developed by Google. It uses a combination of hash values to minimize memory indirections and make lookups faster. Interleaved processing is another method to consider. Memory access latency can be a significant bottleneck. By interleaving the processing of multiple packets, you can prefetch the necessary data into cache while working on other packets, thereby reducing memory stalls. Loop unrolling is a technique where you reduce the overhead of loop control by processing multiple iterations of a loop in each pass. This not only reduces the cost of evaluating loop conditions, but also allows for more efficient use of parallel instructions by the CPU. After applying these techniques, you might find that you've significantly sped up your code. However, there are trade-offs. Techniques like inlining and loop unrolling can increase the size of your code, leading to instruction cache misses. Prefetching too much data can evict useful data from the cache. Using AVX 512 heavily can slow down your CPU clock speed. And of course, more complex code can be harder to maintain. The final technique is benchmarking. Continuous measurement and testing of your code's performance are crucial. This helps identify bottlenecks and ensures that optimizations are effective. In summary, achieving the fastest code involves a combination of practical techniques, thoughtful trade-offs, and continuous benchmarking. In today's episode, we explored the evolving strategies of AI companies, the balance SaaS companies must strike in their free offerings, and the techniques to optimize networking code. Stay tuned for more updates. Dear friends,